When doing calculations such as addition, subtraction, multiplication, and division, it's important for us to only be as precise as our data allows us to be. Now, in the last video, we discussed uncertainty in our measurements. In this video, we're going to talk about how we can utilize significant figures and their rules to maintain consistency with our calculations. Now, there are three main rules for identifying significant figures. The first rule, non-zero integers. All non-zero integers are considered significant. The number 123.4, for example, would have 4 significant figures because 4 of the values are non-zero integers. The second rule is in reference to zero values, and there are 3 sub-rules when it comes to zeros that you need to be aware of. The first sub-rule is leading zeros. Leading zeros are all zeros that precede non-zero digits. These do not count as significant figures. In the number 0.045, for example, there are only 2 significant figures because we don't count the leading zeros in front of the non-zero values. Now, the second sub-rule for zeros is captive zeros. And captive zeros essentially are zeros that fall between non-zero digits. Captive zeros do count as significant figures. The number 10.08, for example, has 4 significant figures, the 2 non-zero values, and then the zeros that fall between. And the last sub-rule is trailing zeros. Trailing zeros are zeros at the right of the number. Now, this one gets a little tricky because if you have a trailing zero and there's no decimal place, it's not significant. If you have a decimal point, then it is significant. The number 100 only has 1 significant figure, but the number 100 with a decimal point actually has 3. The third and final rule for identifying significant figures is in regards to exact numbers. Many times calculations involve numbers that were not obtained by measuring devices, but simply just by counting. 5 apples, 10 experiments, 3 molecules. These numbers are all exact numbers. They can be assumed to have an infinite number of significant figures. Now that we've talked about how to identify them, how do we use them? It's actually relatively simple. For multiplication and division, the number of significant figures in the answer is the same as the number in the least precise measurement used in the calculation. For example, 4.56 times 1.4 gives us 6.38. Here, 1.4 is our value with the least number of significant figures, so we have to change our answer to match it by rounding. 6.38 would round up to 6.4. The product should have only 2 significant figures because 1.4 has only 2 significant figures. Lastly, for addition and subtraction. In addition and subtraction, the answer has the same number of decimal places as the least precise measurement used in the calculation. For example, if we try to find the sum of 12.11 plus 18.0 plus 1.013, that would come out to equal 31.123. The correct answer here is 31.1. Since 18 has only 1 decimal place, we have to round our answer to match that.